Hello and welcome back. Let's continue to use the law of cosines to find information out about a triangle. So here we're given a triangle and we're told that the side lengths are 6, 8, and 10, but we're not told any of the angles. So the question is, can we find the angles in a triangle when we're only told what the sides are? Well, one sort of attempt to try to find the angles of a triangle might be to use the law of sines. So what does the law of sines say? It says that the ratio of the sine of an angle to the opposite side, so here is going to be 8, is equal to the sine of every other angle, the ratio of any other angle to this opposite side. So the sine of b over 6 is going to be equal to the sine of c over 10. So here, when we look at this, well, I don't know a, I don't know b, and I don't know c. So there's no way I can solve for just a by itself without having a b or a c in there. Knowing a, I would have to either know what b or c is to figure that out. So for the law of sines, this doesn't quite work this far. But the law of cosines, on the other hand, so let's take c squared is equal to a squared plus b squared minus 2ab cosine c. Again, notice the side by itself on this side of the equation is the same as what angle we're looking at. So here we've got all of this. Well, we know what little c is. That's going to be the side length opposite c. We know what a is. We know what b is. We know what a and b. We can solve for c quite easily. So let's plug everything in and solve for this cosine. So c squared, so c is going to be the side opposite the angle c, which is going to be 10. So 10 squared is going to be equal to a squared, which is the side opposite a, which is going to be 8, plus b squared, that's the side opposite b, minus 2 times a, which is 8, times b, the side length opposite b is 6, times the cosine of, capital C, which is this angle here that we don't know. So let's solve for the cosine of c, and we're going to see something silly kind of pop out here, but it is expected. So if I'm trying to solve for the cosine of c, I'll do some algebra here. I'll take 10 squared and I'll move the 8 squared to the other side. I'll move the 6 squared to the other side, and I'll divide both sides by -2 times 8 times 6. I'm going to simplify the side first. So if I take the top, which is going to be 10 squared, which is 100, minus 8 squared, which is 64, minus 6 squared, which is 36, I in fact get 0. So what you'll notice is that 10 squared minus 8 squared minus 6 squared, this is just 0, and 0 divided by anything is 0. So we know that the cosine of c is just a 0, is 0 degrees. And this is one of the special situations where I know what c is without having to do any work, because this is one of our special angles. If I draw a little picture here, the cosine of an angle is going to be x divided by r, right? So x here, I can just think of cosine of c as 0 divided by 1. Well, if x is 0, that means we're no farther to the left or to the right, and we're perfectly up, and we're perfectly along here, and we're going to be, in fact, exactly r up. We're, in fact, 1 up, and that is a right angle. C is exactly a 90-degree angle, which is quite nice. It's quite interesting. So C is going to be a right angle in our picture up here. So that's quite nice. Let's do the same thing, but let's do the same thing maybe for the angle A up here. If I wanted to use the law of cosines to find the angle A, how would that work? Well, I need A to appear in the formula. So I want to take the cosine of the angle A, which means that on the other side, I'm going to have the same letter. So I'm going to have A squared. It's going to be B squared plus C squared minus 2BC. So again, we have the angle and the side opposite are going to be these special ones over here. All of the other sides are going to be the other ones. So B and C, we'll just fill in everything there. So let's fill all this in. A is 8, B is 6, C is 10. It's 8, so we'll have 8 squared is going to be equal to 6 squared plus 10 squared minus 2 times B, which is 6, times C, which is 10, times the cosine of A. So again, if I solve for the cosine of A, what I will get is going to be 8 squared minus 6 squared minus 10 squared. There we go. Divided by 2 times 6 times 10. This is not something that I can do very easily in my head, and it doesn't cancel out like the last one did. So let's write all this down. So we've got, I'm going to put this as a fraction. So we've got 8 squared minus 6 squared minus 10 squared all over negative 2 times 6 times, oops, not point, 2 times 6 times 10. It does simplify down very nicely, but it is going to be 0.6. 0.6. And here, if I know that the cosine of A is 0.6, I'm going to say that the arc cosine of A, or sorry, I always make this mistake. The arc cosine of 0.6 should be equal to A. So when I plug this into my calculator, my function, I have the inverse cosine of 0.6, and that's going to be equal to 53.13. And this is in fact the only thing that we need to do for the cosine, as opposed to the sine of an angle. The cosine will be different for acute and obtuse angles. So there's no ambiguity here. It has to be this angle. It's only for the sine that we have to worry about, oh, could it be the obtuse angle or could it be the acute angle? We've used the law of cosines here, but we didn't necessarily have to. We could use the law of sines. So let's come back up here and use the law of sines to figure out B. So for instance, I know what C is. C is a 90-degree angle. So I could use the law of cosines, the law of sines, and figure this guy out. So let's come down here and write that down. So we've got the sine of B over 6 is equal to the sine of C. So the sine of, we said C is a 90-degree angle, over 10. And the sine of a 90-degree angle, again, this is going to be y divided by r. And here is our picture from before. If x is 0 and r is going to be 1, so this distance here is 1, well, that means we're up here at 1. The sine of a 90-degree angle is 1 divided by 1. So the sine of a 90-degree angle is exactly just 1. So the sine of b over 6 is 1/10. Or if I solve for the sine of b and multiply both sides by 6, I get this, the sine of b is 6/10, or 0.6. Okay, that's quite nice. And then we have the arc sine of 0.6 is going to be our angle B, which, if I plug this into my calculator, I've got the arc sine of 0.6. That's going to be equal to 36.87, if I round that. And since we are in in a triangle, and our angles could be acute or obtuse, there is a second possibility. Is it this guy, or is it the obtuse angle with the same measurement? Or is B equal to 180 degrees minus this guy, which is going to be 180 degrees minus that guy, which is 143.13. So the question is, which one is it? Well, we know that the angles in a triangle have to add up to 180 degrees. So we know A. We know C. We don't know B yet, and this has got to add up to 180 degrees. Well, this is pretty easy. If I just solve for B here, B is in fact going to be 36.87 degrees. So we knew that it was this from the get-go. We didn't even have to use the law of sines here because we knew that there's 180 degrees in the triangle. So this is just a very brief introduction to the law of sines into the law of cosines, remembering that the law of sines has a little bit of ambiguity. The very last thing I want to do is a very quick overview of what's called Heron's formula. And this, if you're given a triangle and you know all three side lengths of the triangle, we can find the area of that triangle. We don't even have to know any angles in here. All we need is the three sides. There's two steps to this though. We have to figure out what S is. And this is called the semi-perimeter. The perimeter of a triangle of any shape is just going to be how far it is around. So it's just going to be the lengths of the sides. The semi-perimeter, semi meaning half, it's going to be half of the perimeter. And all you do is you plug it into this formula. You take the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. It's just a very straightforward formula. There's not a whole lot going on. So let's find the area of this triangle. We saw that a 6, 8, 10 triangle was a right angle triangle. So let's find S first. So S is going to be 6 plus 8 plus 10 divided by 2. 6 and 8 is 14, plus 10 is 24, divided by 2 is 12. So the area is going to be the square root of 12 times S minus A, so 12 minus 8 times 12 minus 6 times 12 minus 2, just each of the sides. So it's going to be the square root of 12 times 4 times 6 times 2. And if we plug all this into our calculator, this is in fact going to be 24. And there's our area. It's just as simple as that. On the other hand, I want to quickly point out that we still have our old formula, which is going to be 1/2 the base length times the height. And here, the height of this triangle is 6. The length is going to be 8. So we still get the same answer if we use Heron's formula, or if we use the area, the 1/2 base times height.